Hi everyone, and welcome to Unit 3, in which we'll be talking about how to solve inequalities. Today's lesson is specifically 3.1, which is our formal introduction to inequalities. And by the end of this video lesson, you should be able to read, interpret, graph, and write solutions to inequalities. So let's begin our journey into Unit 3. The first thing that we need to become familiar with are the inequality symbols that exist. They are the greater than symbol, less than symbol, greater than or equal to symbol, less than or equal to symbol, and not equals to. All of these you are familiar with. You have seen them before, you have heard them before, and you have used them in different capacities. Now we're going to use them within algebra. Essentially, what inequality symbols tell you is that one side of your statement is greater than or less than the other side of your statement. So one side will be bigger than the other. The next important thing is to know how to read inequalities. So how do you read them? Think Pac-Man. Pac-Man is hungry and always wants the bigger meal. Therefore, the inequality symbol opens up to the side that is the greater or the bigger or the larger side. The biggest rule of thumb that I teach students is that you want to begin reading your inequality with the variable first. So there are two examples down below. Let's take a look at them. I see that there's a -9, an inequality symbol, and an x. I'm going to begin reading this with the variable first. So x is smaller than, or in other words, less than -9. And again, x is smaller because it is behind the inequality symbol. Or in other words, it is behind Pac-Man. And as you know, Pac-Man wants the larger meal. So that makes the -9 bigger. Now let's take a look at the example below this. In this example, the variable comes first, then the inequality symbol, and then the -9. So x is less than -9. I know that x is smaller than -9 because x is at the back of the inequality symbol, or in other words, in back of Pac-Man. And remember, Pac-Man, or your inequality symbol, will always eat or open up to the larger side. So a common question that students have is, how is it that the two examples up above can be translated into the same sentence, although the 9, the inequality symbol, and the x have all flipped their position? So, the reason being is because the x is at the back of the inequality symbol in both examples. Therefore, it means that the x is the smaller side in this statement. Because of that, the statements are read exactly the same when you begin reading with the variable first. X is less than -9 in both of these examples. All right, so interpreting inequality solutions is super important. Inequalities have multiple answers that make the statement true, or in other words, make the statement correct. When interpreting inequalities, you are identifying the solution set. The solution set are all the possible values that, when plugged into the statement, make it true. There are many answers that make an inequality statement true. Now, let's discuss what you'll need to know in order to graph one variable inequalities. One variable inequalities are graphed on a number line. There are some nuances that you will need to remember in order to do this successfully. You will first place a circle over the initial number in your solution. The type of circle you use depends upon the given inequality. You will then draw an arrow in the direction that contains all the numbers included in your solution set. This is super duper important. If you have a greater than or equal to sign or a less than or equal to sign, that means that the number in your solution set is included. I will start counting at that number when I'm writing out my solution set. To indicate that a number is included on my graph, I will do that by using a closed circle, meaning that you will shade the circle in. If I have a less than or greater than symbol, meaning that the equal to sign bar is not there, that means the number that I've solved for is not included in my solution set. And to indicate that when graphing, I will need to use an open circle on the number that I've gotten when I've solved. Now let's turn to the next page and begin to apply the stuff that we've talked about. But just before doing so, just to check for your conceptual understanding, I've given you two pictures here. Pause the video and come up with the correct statement that describes what is being shown in each of these pictures. I'm assuming that you've clicked play, and the correct statement for A is that x is equal to 2. In this case, we'll use an equal sign because the weight of the x on the left side of the balance beam is equal to the weight on the right side of the balance beam. And I see that there's 2 cubes on the right side, so therefore I have a statement of x equals 2. And again, I can use the equal to sign here because both sides of the scale are level, or in other words, they are balanced. In photo B, you'll notice that one side is heavier than the other side. The x side is weighted more heavy or lower, so therefore x has a greater weight than the 2 cubes that are on the right side. So therefore, if I was writing this as an inequality statement, x is greater than 2. Now, the last thing that we're going to do before I ask you guys to complete the student pages is to put everything together that we've talked about today. So, with the examples down below on the teacher page, we're going to write the description. We're going to list out all the numbers that will be included in our solution set, and then we're going to graph it. And I've placed a reminder for you that you want to begin the description with the variable first. So with this first example, the x is at the back of the inequality symbol. So therefore, x is less than 5, or x is smaller than 5. To talk about all of the possible values, since there's no equal sign here, that means that 5 is not included in my solution set. So when I list out the possible values, I'm going to count on from the next numbers. So 4, 3, 2, 1, 0, -1, -2, etc. You see me putting 3 dots behind this -2 because realistically I cannot write all the numbers that satisfy the solution set because all these numbers go towards negative infinity, and I can't write to negative infinity, nor can you. So to graph this, I'm going to place an open circle on 5. We are using an open circle because it indicates that 5 is not included in our solution set. So go ahead and place an open circle on 5, and then we're going to draw an arrow towards the left because this is where all the numbers towards negative infinity are captured. Make sure that there's an arrow on top indicating that all of these numbers could be considered a part of the solution of x is less than 5. Now looking at the next question. X again is behind our inequality symbol. In this case, x is less than or equal to 5. I include the words that or equal to because that single bar underneath the inequality symbol lets me indicate that 5 is included in my solution set. So if I were to write out my possible values, I can start with 5 and then listing all the numbers that are smaller than 5. So 5, 4, 3, 2, 1, 0, -1, -2, -3, etc. Again, that's why I'm placing the 3 dots to indicate that it's going towards negative infinity. Because 5 is included, I'm going to put a closed circle on 5. I'm going to shade it in. And then again, I'm going to have an arrow going towards my left, pointing in the direction that houses all of the numbers that we've just listed out. So all of the numbers going towards negative infinity. You have to make sure that there's an arrow on your line when it's drawn to show that it's encapsulating all of those numbers that are 5 and below. For our next example, the inequality opens up towards our x, so therefore x is bigger. So our sentence will read, x is bigger than, or x is greater than 5. The possible values that we can include here are 6, 7, 8, 9, 10, etc. I am not including 5 because that equal to bar is not present in this inequality symbol. It's simply x is greater than 5. So I'm listing all the numbers that are bigger than 5. I will place an open circle on 5, and then my arrow will be going towards the right. All right, our next example. Again, the inequality symbol is opening up towards our x. So x is greater than, and in this case, or equal to, 5. Because of the single bar underneath our inequality symbol, which again indicates the equal to sign. If I am to list out the possible values that x is greater than or equal to, that means I am going to include 5 in my solution set. So 5, 6, 7, 8, 9, etc. When graphing this, I will have a closed circle on 5. And again, my arrow will go towards the right side. Notice that I'm drawing the arrow above the number line and not on it because I want it to be visibly clear as to what side I'm indicating my solution set is pointing. And for our last one, we have an equal sign, so x is equal to 5. The only number I can include in that solution set is 5, and I will have a closed circle on 5. No arrows pointing in either direction because the answer to this cannot be any other number but 5. All right, so that concludes the end of this lesson. And you guys will demonstrate your level of mastery and what you've retained from this lesson by completing this student page. Please remember that our goal for this lesson is that you should be able to read, write, interpret, and graph solutions to inequality symbols. So go ahead and complete the student page, and happy holidays, guys.